For basically all of human history, the dark side of the moon has been a total mystery. Well, until now. Turns out China just brought back some rocks from it, and deep inside that lunar dust, they found something tiny that could completely rewrite the story of water in our solar system. Okay, let's get into it.
So first off, why is there even a far side to begin with? Well, it all comes down to this really cool phenomenon called tidal locking. See, the moon rotates on its axis at the exact same speed that it orbits around the Earth. And what that means is the same face is always, and I mean always, turned towards us. That's left the other side a complete unknown, this frontier that has fascinated and mystified us for centuries.
And here's where it gets really interesting. The two sides are shockingly different. The near side, the one we all know and love, the man in the moon, it's got a thinner crust, it's covered in these huge, dark, smooth plains we call maria, or seas. But the far side? Whoa, it's a completely different world. The crust is much, much thicker, and it is just absolutely pummeled with craters, a rugged, ancient landscape we didn't even get a glimpse of until 1959. So we're not just talking about a different view, this is a totally distinct and mysterious place.
And that brings us to the hero of our story, China's Chang'e 6 mission. Now, this was not just another trip to the moon. This was a dedicated journey into that unknown territory, and it had an incredibly ambitious goal.
And that goal? To do something no one, and I mean no one, had ever done before in the entire history of space exploration. Bring a piece of the far side back home to Earth. This is just a monumental achievement, giving us our very first physical samples from this hidden hemisphere.
So where did they go? They targeted a very specific spot, the South Pole-Aitken Basin. This thing is a colossal impact crater that covers nearly a quarter of the entire moon's surface. And why there? Well, because a giant, ancient impact basin is the perfect place to go hunting for debris from the early solar system. You know, cosmic shrapnel that could hold the very secrets to how everything, including us, got started.
With the samples safely back on Earth, the real hunt began. Scientists started sifting through all this gray lunar dust, looking for clues. And what they found, well, it wasn't some huge, obvious discovery. Nope, it was microscopic. But the implications? Absolutely massive.
And let me tell you, this was painstaking work. Just try to imagine looking for a needle in a haystack, except the haystack is from the moon, and the needle is smaller than a grain of sand. You're talking about a team of geochemists carefully, meticulously sorting through more than 5,000 tiny little fragments of lunar material. So how'd they even find it? Okay, so first, they combed through all those thousands of fragments. They were specifically looking for tiny bits that contained olivine, which is this green mineral that's kind of like a key signature for certain types of meteorites. Then came the heavy science, really detailed chemical and isotope analysis. And out of that whole intense process, they managed to pinpoint just seven unique fragments that were unlike anything ever seen in lunar rock before. And this is what it's all about. As the report on the finding put it, the dust from the moon's far side contained an unexpected microscopic treasure. It was something completely new, something that, by all accounts, shouldn't have even been able to survive on the moon. Just think about that for a second.
So what was this treasure? Well, it was debris from a very special, very rare type of meteorite known as a CI chondrite. And you gotta understand, these are not just any old space rocks. These are true cosmic time capsules.
So a CI chondrite, right? It's a type of carbonaceous meteorite that formed way, way back at the very dawn of our solar system. They are incredibly rare, incredibly fragile, and, most importantly for our story, incredibly rich in water.
And this is the wild part. Their composition is basically a recipe for a planet. Up to 20% of their entire weight is water, locked away inside these hydrated minerals. They're also packed with organic compounds, the basic building blocks of life. They are essentially cosmic sponges, just soaking up all the ingredients for a world just like ours.
But here's the catch. The very thing that makes them so special is also what makes them so fragile. They are unusually soft and crumbly, which means they almost never survive the violent journey through Earth's atmosphere or a high-speed impact on the moon. They're expected to just vaporize or melt completely. Finding fragments of one is like finding a perfectly preserved snowflake in a furnace. It shouldn't be possible.
And this is where it really clicks. Here on Earth, these fragile CI chondrites, they make up less than 1% of all the meteorites we find. They just burn up in our atmosphere. But on the Moon, with no atmosphere to destroy them, this new analysis suggests they could be way more common. It basically proves the Moon is a much, much better archive for this pristine, ancient material.
So what does this all mean? Why does finding 7 tiny specks of dust matter so much? Well, because finding them provides the key piece of evidence to help solve one of the biggest mysteries about our home planet. Where in the world did all our water come from?
This discovery is, and I'm not exaggerating here, the first direct physical evidence we have ever found of something scientists have suspected for decades. The idea that asteroids delivered water to a young, dry Earth has been a leading theory for a long time.
But it was just a theory. Until now. This is the proof, preserved in the one place in our entire neighborhood that could keep a secret for 4.5 billion years.
So let's just trace the story here. About 4.5 billion years ago, boom, the solar system forms. Then, during a period of intense early bombardment, the theory went that these CI chondrites slammed into the inner planets delivering water. And now, today, Chang'e 6 has brought back the physical proof, the smoking gun that's been preserved in the lunar dust for eons.
So the big takeaway here is this. The Moon's far side isn't just a barren, cratered wasteland. It's a pristine, deep-frozen archive of the early solar system. Because it has no atmosphere and no real geology to speak of, it has preserved the evidence of our own origins, evidence that was wiped clean here on Earth a long, long time ago. I mean, this discovery is a huge clue to figuring out how Earth became the water world we know and love. But it leaves you with an even bigger thought, right? If the proof for our planet's water was just sitting there on the Moon this whole time, what other fundamental secrets about where we come from are just waiting to be discovered in that lunar dust?